Hello! Welcome to the Process Plant Sciences Lab at Montana State University Billings City College. Today we're going to be working on a lab where we explore freezing points of solutions of either glycol or methanol. This is important because we use these chemicals in an industrial setting to protect equipment from freezing. We're going to be using materials in today's lab that have some hazards associated with them. First is dry ice. It's at 109 degrees Fahrenheit, below zero, and it'll cause frostbite if handled. Always wear gloves when handling dry ice. As always, safety glasses or goggles are required in the lab. The next material is methanol. This is a highly toxic substance. Less than an ounce will blind you, and 1 ounce will kill you. That's why no food or drinks are allowed in the process plant lab. We also need to be familiar with the MSDS sheet, which is posted on D2L. And then finally, glycol. It's also toxic. In 2007, about 1,000 people were poisoned from it, and 16 people died from it. Its hazards are exacerbated by the fact that it has a sweet taste. That's why pets will drink it if it's out in the garage in a pan, especially hazardous to children. But it makes me nervous because if it did accidentally get into something someone was drinking out of, you wouldn't necessarily taste it. I think in the United States it's bittered now, but I wouldn't want to bet my life on it. Again, that's why we don't allow food or drinks in the lab, and the MSDS sheet for the material we're using is also posted on D2L. For this lab today, freezing point lab, we're going to take temperatures of the freezing point of solutions of water and either glycol or methanol. And because those freeze below the normal freezing point of ice, we need some way to get it quite a bit cooler than ice normally is. And so what we'll be using is dry ice. And I have a cooler here, and you can buy dry ice from most grocery stores now. And it's about $10 for a 5-pound block. We won't need a whole lot. It'll last about a day in a cooler. They'll tell you it'll last longer than that, but my experience is not much longer. And we're going to want to chop it up into kind of like a pebble size. And the easiest way to do that is just wrap it up in a old rag, and we'll kind of break it with a wrench or a hammer. You'll need gloves to handle dry ice. It's about a negative 109 degrees Fahrenheit, so if you pick up a piece of dry ice, you run the risk of getting frostbite. Let's see how that looks. Oh, that's great right there. And then what we're going to do is I'm going to put that into a beaker. And now we're going to try to freeze a test tube of water or water and ethanol solution, whether water and methanol solution or water and glycol solution. And what you'll find is if you just put a test tube into this beaker of dry ice, it doesn't make great contact with the test tube, and so the test tube is going to cool down very slowly. A better way to do it is to make a dry ice bath. And what we'll use is acetone. Now acetone freezes below the temperature of dry ice, and so it's not going to freeze. If you try to do this even with straight glycol, it's going to freeze on you, and you're going to just have a block of whatever you mix in there. You can see that bubbles up pretty good. My acetone's very hot because it was sitting out in the sun, and it's about 90 degrees outside today. And so you can see that's bubbling and churning pretty good right now. And so now I have something that I can put a test tube in that's 109 degrees below zero. And so that'll be real convenient for our experiment today. For the next part of the lab, we're going to try to freeze a little sample of water in a test tube, and we'll just check to see how our apparatus works. And what I'm going to do is I'm going to sit that test tube in there, and you can see I can move that. It's not frozen solid. I can put that in there, and it'll start cooling on me pretty quick. Now it's going quickly now. And what I'm going to do is I'm just going to watch it and see where it freezes. And there'll be a little judgment in there if we. And so you see, as I was cooling it down, the temperature was dropping, and I'll try to zoom in on that a little bit for you. And then when it got right to the freezing point, it held at the freezing point. And then as it all froze, when it all froze and it was just a block of solid ice, it began cooling again. And right now it's at negative 14 degrees C, and it's out of the dry ice, and it's just warming, but it'll warm very slowly just in the air. Next thing I'm going to do is I'm going to make a solution of 50-50 glycol and water. And what I have here is just some ordinary glycol I got at Walmart, antifreeze coolant. I imagine it's ethylene glycol. I don't remember. Ethylene glycol, it has diethylene glycol and some other ingredients. So there's our solution, 50-50 glycol and water. And then I'm going to try to go a little slower on this one. I'm going to just keep stirring it as I go. You can see the graph there. It comes down. It's a little rough, and that's because when I'm shaking it, the thermocouple is moving from the center of the glass to the outside, and you get some variability there. Right now, we're at negative 34 degrees Celsius, and I'll zoom in right to the container, and you can see what I'm seeing in terms of how I'm freezing it and what I see in the test tube. There's a little frost on the outside of the container, but you can see the fluid inside the container is clear. No solids in it. Now I'm seeing some ice on the inside of the test tube now. That's on the inside. That's not on the outside. And so I'm starting to get some crystals of ice forming inside the test tube. If I hold that for you and stir it around a little bit, you can see there's ice in there. And so I'm at a point where this is turning into slush on me. What we'll do is we'll let that warm up and we'll see what it does. We're at about negative 30 degrees Celsius, and there's still a little ice in there, but it's clearing up. I would say it just cleared. It's at negative 30 degrees Celsius.
Your lab assignment is posted on D2L. But a couple of things to think about while you're conducting your lab is what would it take to create a graph of freezing point versus concentration? Number two, is methanol more effective than glycol? I've heard people state that if you use methanol, it's a better solution for freeze protection because you only need a small amount of methanol to get the same amount of freeze protection as glycol on a volume basis. Number three, at what concentration is ethylene glycol most effective? In some situations, more is better, but not in all situations. This is a situation where more isn't always better. And number four, methanol is cheaper per barrel at about $150 per barrel than glycol is at $750 per barrel. But it's quite a bit more toxic. Which is a better choice in your opinion, and why?